Earlier in the course, we talked about priority queues. In priority queues, items get removed from the queue based on their priority, not when they join the queue. Priority queues are very popular. For example, your operating system uses priority queues to schedule tasks. Tasks that have a higher priority, they will get executed first, okay? So earlier in the course, we built this priority queue class. In this implementation, when we add a new item, we have to shift the existing items to the right to open space for the new item. Let me show you. So back in the main class, let's create a queue object and add a few items. So 30, 20, and then 10. Now let's print this queue on the console. So our queue has the capacity of 5. The 30 is at the front of the queue because it has a higher priority. And the 10 is at the end of the queue, okay? Now, if we try to insert a new value that is smaller than all the existing values, let's say 5, what do you think is going to happen? All these existing items have to be shifted to the right, so 5 will be inserted at the end of the queue because it's the smallest value. Now, what is the time complexity of this insert operation? It's O of n, because in the worst case scenario, all the existing items have to be shifted to the right. The more items we have, the more shifting operations we'll have to execute. So in this implementation, the time complexity of the insert operation is O of n. What about deletions? Let's take a look. So here is the remove method. As you can see, when we remove an item, we simply decrement the value of the count field. So we're not physically removing items. We are not shifting any items in the array. We simply reduce the size of our queue. And this is an O of 1 operation. So back in the main, deleting an item is an O of 1 operation. Now we can also use a heap to implement a priority queue. What is the time complexity of the insert operation in a heap? It's O of log n. Because when we insert a new item in a heap, that item gets stored in the last leaf. And then if it's not in the right position, we might have to bubble it up until it's in the right position. In the worst case scenario, this item has to travel all the way up to the root. So the distance it has to travel is equal to the height of the tree. Earlier I told you that in a complete binary tree with n nodes, the height of the tree is equal to the logarithm of n. So that is why the insert operation in a binary heap runs in logarithmic time. The same is true for the delete operation. So when we delete the root node, we have to move the last leaf in that position. And if it's not in the right place, we have to bubble it down. Again, in the worst case scenario, the maximum this node has to travel is equal to the height of the tree. So if we use a heap to implement a priority queue, we get faster inserts and slower deletes. So if you have a lot of insertions, it's more efficient to build a priority queue using a heap. Let me show you. That is super easy. So I'm going to add a new class here. Let's call it priority queue with heap. Now, technically, the name of the class shouldn't reflect how it's implemented because that's implementation detail. So this should be hidden from the consumers of that class. But in this course, let's not worry about it because I want you to have all these implementations in one project. So in this queue, we need a couple of operations. One is add, which gets an item, and remove, which removes the item in the front of the queue and returns it. Now, in this implementation, we're going to use a heap. So a private field of type heap. Now, when we want to insert a new item, we simply call heap.insert and give it this new item. Similarly, to remove an item, we call heap.remove and return the result to the caller. So this priority queue class is simply a wrapper around the heap class. We could change the name of these operations to, let's say, enqueue and dequeue. That would better align with the concept of a queue. Also, we need another operation to check to see if our queue is empty. So public boolean is empty. And here we return heap that is empty. So this implementation is essentially a wrapper around the heap class, but it gives us a different interface to work with. As simple as that. So this is how we implement a priority queue using a heap.